But, okay, so now, okay, to continue with integration by parts, I want to look at a problem that works out a little bit differently. So let's suppose that we've got one that looks like this. Let's suppose that we've got e to the x and sine x. Now, this time we don't have we don't have a polynomial and a non-polynomial. We have two non-polynomials, right? So when we pick u to be one of the two parts to this, it's not going to ever go away, no matter how much we differentiate it. No matter how much we differentiate e to the x, it's never going to go away. No matter how much we differentiate sine x, it's never going to go away. So this one is not going to turn out the way the others did when we were using integration by parts. But let's don't think about that. Let's just go ahead and say, well, let's just let u be sine x. And then du equals cosine x. Okay? And then I'll let dv be, of course, the rest of it. Okay? So we've got that. So, yeah, I was going to have to integrate one of them, and I'd rather do e than sine. That's the way I chose it. Okay, now let's see what we've got here. So I've got e to the x sine x, and I've got uv. Okay, so here we go. E to the x sine x. Okay, that's uv minus v du, so e to the x cosine x. Now, it looks like to me we've not bettered our situation, right? Instead of e to the x sine x, now we've got e to the x cosine x. So, not much better off. But let's go ahead and just continue on, and let me do this integration by parts again. So, let me change colors here, and now I'm going to look at e to the x cosine x. So I'm going to just repeat this process now, just like we did before, but now with this second integral over here. Okay? I'm going to go the same way. This time I'm going to let u equal cosine x, and then du, 1, just to distinguish it from that other one, it's going to be negative sine x, negative sine x dx, right? Because the derivative of cosine is negative sine. Okay, now dv, the second dv is going to be cosine x. Wait a minute, no, it's e to the x. Sorry, I gotta. Okay, so dv is equal to e to the x, just like before. And then v is equal to e to the x. Now, what complicates this a little bit is if it weren't just e to the x, if it were e to the 3x, sine 4x, something like that. But I'm doing this simple one just so that we can see the process, and then, you know, the complicated parts can come later, or the parts that make it a little more complicated. Now, so let's see what we've got now. So we've got this. We've got e to the x sine x. So I'm writing the whole thing over. Equals e to the x sine x. Okay. Minus, now I'm going to put in this integral. This second integral here, which is, we're going to say uv. So this is e to the x cosine x. Right? That's e to the x cosine x. Minus v, which is e to the x du. Okay, does that, did I mess up at all? Okay, so it looks like this part right here is this part. Okay. And I just want to v, yeah, there it goes. Okay, everybody good with that? Okay, so you might say, well, you might be thinking, he's gone mad. He's just going to be doing this forever. Because look what we have here. Now, let me just rewrite it like a madman, right? Okay, so here's what I have. I have e to the x sine x. Okay, minus e to the x cosine x. Look at this, 3 negatives, right? That makes a minus. E to the x sine x. Okay, now let me see what happens here. Look at this. We've got e to the x sine x, ha und ha. So let me just bring this over. And I have 2 of these now on this side. Because this is just algebra, right? We can take this integral of e to the x sine x from one side, bring it to the other, and now we don't have 1, we have 2. We're blessed with 2 of them. Yes, I'm a genius. Okay, now if I just divide by 2, I get e to the x sine x, which is what we started with, equals 1/2 e to the x sine x minus e to the x cosine x. Yeah. There we have it. And I think that deserves one of these guys. Okay. Yeah. Okay, so does everybody see that?